Welcome to this special edition of Cosmic Queries, StarTalk. For it, we are in collaboration with a conference being held, a live conference being held by PocketLab, which is an organization that serves the needs of science teachers around the world, with demos and materials and literature. And so they hosted a conference, and we, StarTalk, were invited to do a live Cosmic Queries for their audience during this COVID-separated conference. Thousands and thousands of teachers tuned in for it. So we invite you to sit back and enjoy Cosmic Queries with PocketLab.
Let's just start off with Abby Gandhi. She's coming to us from Ottawa. I hope she's in the room with us now. How can we encourage curiosity in all students given our and their limited resources and time in this coming year? So this seems to be a theme that's running throughout all the questions, the fact that we're learning remotely and that, over digital platforms and that type of stuff. But, that notwithstanding, how do you encourage curiosity?
Yeah, so I don't have a silver bullet there, but what I do know, and I've said this before, that kids, obviously we have kindergarten through upper high school represented among the teachers, and students are different at each of these stages. I get that. I can tell you, and you certainly know, those who teach kindergarten and first through fifth grades, that curiosity is just a built-in feature of what it is to be a kid. And so I think for me, the task of teachers is not so much how to stimulate curiosity, but how to not squash the curiosity that's already there. And that's a different task, right? Because if you know it's already there, then you can nurture it. You can bring in elements, tools, methods that continue to stimulate it so that the child never knows a day without being curious about one thing or another. And one thing I know that squashes curiosity, and I get it, it's got to be a part of the curriculum, I get it, that you got to sort of hand kids information that you then test them on later. I get that. But there's got to be some room, either built in or you pry it open, to put things out in front of the students for which there is no obvious answer. And they say, well, I wonder how you get the answer to that.
Wow.
Or how do I dig? And it's easy to give the example when you're in a yard and there's grass and there might be some flowers or leaves or a tree and you're poking around nature, but curiosity can manifest in practically any discipline. And artists know that you just give a canvas and paint and give it to kids, they'll just start painting, right? That's an act of exploration that you are not guiding. All you're doing is providing the tools and let that creativity unfold. Because for me, curiosity and creativity go together. They're basically the same word when you're a student coming up through the system. So I think if you devote some fraction of a curriculum to just exploring, rather than being there as I'm the one with the answers and you take notes because you'll be tested on it later. Try to find ways to put out even questions that you know the answer to, but they require a little bit of exploration. What did happen, if it's a history class, what did happen when Napoleon tried to conquer Russia? Well, I looked at let's look up the weather for Moscow in December. Oh, it's 20 below. It's this, it's snow. I wonder if Napoleon thought about that. Let's investigate this. You can hand them the answers or you can collectively find the answers together. And for me, that's the difference between learning by being taught and learning by doing and fulfilling your own curiosity. And that would be a way to sustain it. For the youngest of kids, they already have it.
I love that. So kind of reverse engineering the learning process. You start with the answer and work your way backwards.
That's another way to do that, right?
Oh, okay.
But sometimes you don't know what the answer could or should be.
Okay.
And even if the answer is known, if you're learning, you can treat it like it's a brand new kind of exploration of what would you do if you were Napoleon? No, I would have checked out the weather forecast.
I would have checked the weather, right? Yeah, exactly.
check the weather, okay?
Right on.
For the French Revolution, are people eating or are they not?
Right.
Are
Exactly.
you paying attention?
And
Did they pay attention?
and was there enough cake? Was there enough cake? How good were the bakers?
So if you treat something that may even be known as an unknown,
Right.
that's a point of curiosity for everybody. And then everyone stimulates their thoughts and their ideas, and then you go to what actually happened. Then you can criticize or compliment what actually happened. So that's an example, not even drawn from the sciences, but keeping this multidisciplinary as an educational task, and as so many teachers need to think about. So,
Cool.
yeah.
All right, man. Great answer. Great answer.
So what else you got? Bring it on.
I got Alan here.
Is there a last name? Where are they from? Or
Yes. Thanks, Neil. Thanks. This is Alan Wasmoen from Omaha.
Okay,
Wasmoen?
stop pronouncing last names. Never mind.
I know. Alan it was so simple, Neil, with Alan. Alan knows
Take a collection.
Right.
Help Chuck read.
Exactly.
Right?
Alan knows who he is. Alan does not need me to tell him.
Okay, so it's Alan from Wisconsin?
Alan from Omaha. And,
Nebraska. Okay.
Nebraska. Wasmoen, I think it is. But anyway, Alan says this. We hear a lot about anti-science folks in the United States. How do we restore science to its proper status among the general populace? So is there anything that you can do to create a greater respect for science, especially in light of our leaders? And I'm not being political, but our leaders, I'm not, but they tend to poo-poo science. I mean, you have a number of governors who are defying their public health officials. You have people saying, don't wear a mask. You have people saying, and so this has got to have a deleterious effect on the way people view science.
So again, I don't have a silver bullet here. I think here's the answer I don't want to give, but I'm going to start with it. I wish I didn't have to give this answer because I don't like this answer, but it could actually work, is if every science research program came with a fraction of its budget for advertising. And you just advertise what science is doing for you in your everyday life. Because science is there in ways that we all take for granted. Oh my gosh, how many people did not die in childbirth who are alive today simply because advances in medical science?
Thanks, science.
Or thank you. So you would just every day you'd see a public service announcement. Here's what science does for you.
Right.
And here's what led to that discovery. Oh, you had an MRI measurement today? Where did that come from? It came from this physicist who got a Nobel Prize for that discovery. Did he care about your health? No, he cared about molecules in space and won the Nobel Prize. That piece of information got picked up by a medical technologist and became a machine that diagnoses your health. A reminder of this. And yes, it's advertising. I hate advertising because it's always designed to make you do what you don't want to do. But if it's a public service announcement every day, maybe that would have some influence. Just maybe. I'm tired of hearing people, I don't like the space program. Oh, let me find out what the weather is for next week on my satellite TV.
Right.
And people have lost track of what role science, innovative science, engineering, and technology play in not only their health, their wealth, their security, but just in whether or not they can enjoy life. And so there needs to be a better marketing plan. And that's the answer I don't want to give. Let me give another answer that's directly related to our audience today, which is 10,000 science teachers around the world. I think, and I'm just putting this out there, I think if some portion of your curriculum were devoted to teaching science not as information, but as a way of querying nature. Okay, we hinted on this in developing and curating curiosity. But think about it. If you learn what science is and how and why it works, then you're not going to grow up and say, oh, I distrust science or what those scientists are telling me, because you will understand what it is, where it's coming from, that there's an experiment, there are observations that have been confirmed that led to research results that are arriving at these conclusions. You'll understand the entire anatomy of that understanding, the anatomy of those statements that are getting made. And I'll give you a real good example of this. At the beginning of the coronavirus, where it's rising in the United States, early March, it was like, wear a mask, don't wear a mask. Seemed like there was conflicting information. You know why there's conflicting information? Because at any given moment, you plug in all the information you have. And the information you have at any given moment for a new and novel virus, you're gathering it. You want to know it immediately. You don't want to wait to 6 months for all of these tests. So we're giving you this as it comes across, and kind of in real time. And then we find out, no, this is not working. Do this, okay? What I'm saying is, yes, that was changing because new information was informing it. It wasn't changing because they said, well, let's try something else. I don't know. No, new data was informing it. And that's how science works. Okay? I'm screaming at you. I'm sorry.
No, man, I like it. I love the passion. I like the passion.
That's how science works.
You're like the Samuel L. Jackson of science right now.
Just angry with everything. Just talking. So if that's
Say
how
science again.
To my face. So if that's how science works, then you'll understand that arc through something that is brand new that we're experimenting on in the laboratory. And you'll also know that the people who don't have that kind of access are like your neighbor or your mayor or your governor, unless they themselves are listening to the medical experts who are plugged in to that flow of research. And so when they say, oh, scientists used to think this and now they think this, therefore I'm not going to believe any of it. No, that's not how this works. That's not how we got to the civilization that we have today. So it means teaching science in a slightly different way, to understand that it is a way of arriving at what is objectively true in the world. Then you get them early on, and then when they become mayors, some of the students of these teachers are going to become mayors, very powerful people, heads of captains of industry and the like. They will then have this understanding so that they be in a position to try to convince an electorate that if they're angry and you want to take off your mask, that has consequences that we have researched, and the consequences you don't want because it could make it worse later. And so that's what I got to say.
All right, man.
I'm gonna calm down.
No, that's very passionate. I really enjoyed your. Okay. I enjoyed it. You know what I mean?
All right.
It's very cool. All right. So this is Amanda, and Amanda Watson wants to know this. I'm in my 30s. Do you think we will colonize Mars or the moon in my lifetime? Okay. And then Amanda Phillips says, what are some of the space-related activities that can be done with preschool students via long-distance learning? So
wow. Okay. So there's two different Amandas.
Doubling up on you. Two different Amandas.
Two different Amandas. Okay. So again, that one was, the first one was what?
Colonizing the moon and Mars. She's in her 30s in her lifetime. So yeah. let's say she'll live to 130.
Okay. Back in the day, like 50 years ago, 100 years ago, people imagined we would never get to the moon because of how hard the task was or what challenges it would bring upon us. And then we got to the moon, and then people's attitude towards such achievements shifted. It actually did 180. And people said, oh, we went to the moon, now let's go to Mars, right? No longer were there people saying what was or was not possible, because we did the impossible. So I will now tell you, I think not in your lifetime will we colonize either the moon or Mars. Not because we don't know how to do it, not because we couldn't figure out how to do it, but because I don't see the motivation to be there. Yeah, you could want to do it, but at some point, somebody's got to write the check. Somebody's got to sign the check. And what is their motivation to do it? Is it just, oh, let's just do it? No, there's going to be, what drives it? Power drives it. Military dominance drives it. Economics, the prospect of making money drives it. The great drivers in the history of civilization. And so great as in the most powerful drivers. I'm not value judging it. I'm just stating it. So if we colonize Mars, it would be because there was a geopolitical reason to do so. And then eventually, yeah, maybe you can make a buck off of it. You send tourists there, this sort of thing. You have a lottery ticket. And you can imagine scenarios where you can start making money on this. But I've said many times, there are other ways to make money in space. Go mine an asteroid for its natural resources. And the first trillionaire ever will be the first person who exploits the natural resources of asteroids. So it's not like space couldn't be an excellent frontier, but to colonize, you want to actually go to the moon and live there? You want to go to Mars and live there? Do you know that Antarctica is warmer and wetter than any place on Mars? Yet I don't see people lining up to go buy condos in Antarctica. So you have to just factor all this in. I can imagine an outpost that you go and vacation there for a week. I can say, oh, I was on the moon for a week. But to live there and that'd be your only place, I don't see that. I don't feel that happening. So maybe tourist trips to the moon in your lifetime.
So there you go. There'll be no colony, but there will be Airbnb. So there we go.
And maybe even restaurants, but they probably have no atmosphere.
Oh, no.
Had to throw that one in.
Oh, you did it to me, man. You did it to me.
Okay, now
right.
also,
do you have a space related activity that could be done with a preschooler?
Yeah, so it's not about going into space, but at least about thinking about what's happening over your head. With preschoolers, get them to notice the moon and have them draw the phase of the moon tonight, okay? And then tomorrow, have them draw the moon again. And then the next day, have them draw the moon again. And they will see the shape of the moon is changing. It changes. And by the way, if you go back at the same time to draw the moon, it's not in the same place. It's in a different part of the sky. Oh my gosh, it moved. Oh, and so then you learn the moon orbits the Earth. And you can do experiments in a classroom. You turn out the lights, close the blinds, and get a flashlight, and you get an orb, and have kids all observe the orb when the flashlight is illuminated from the side. It's going to be a half-lit orb. It's like a half moon. And then as you change your angle, you can see the crescent, you can see the full if the light is from the other side. And so you can start thinking about the machinery of the solar system in that way. And the moon makes a great target for this because it's a nice long project. It takes a full month and kids can think about it. And then you do the experiment in the classroom. That works for preschool right on up.
So when do you tell them that the moon is made of cheese? When do you
save that for the very end?
Good answer, man. That's a damn good answer. All right. This is Amy Monahan from Dayland. She says, for beginning stargazers, what do you recommend to start? So I'm a young Neil deGrasse Tyson. What do I need to get into stargazing?
Okay, first, a pair of good binoculars, which is not all that expensive. I haven't checked lately, but I think you can get a pair between $50 and $100. And if that feels like a lot of money, consider that you buy it once in your life. And so just amortize that over between when you buy it and when you die, and ask, what does that cost per year relative to other things you consume daily? So that's how you need to think about that purchase. I still have binoculars today that I used 40 years ago because I'm that old, right? So
binoculars are that good.
Well, yeah, both. And so with a good pair of binoculars, what's good about it is they're good at night. You can see the moon and the craters and the phases. You can, if depending on how good they are, the upper end of that, you can see the rings of Saturn and the moons of Jupiter. You can see that Venus goes through phases like the moon does. This freaked out Galileo. It didn't freak him out. He said, wait, that means Venus is going around the sun, not just around the Earth. For it to go around the sun to go through phases. So that meant something else was going on than what everyone was teaching you in the day. So, and binoculars are great for sporting events and for bird watching and the rest of that. So start with binoculars. And plus, they're easy to sort of hand off to other people. Hey, take a look at this. What do you think of that? And so start there. And then there are stargazing books that can help you identify. Oh, sorry, books. We have apps now. In my day, we had to remember what the constellations look like. Now we have apps where you hold up your smartphone to the sky and it knows which direction you're pointing and what's behind it, and it shows you the object, and you can tap on what everything is. So almost all the sky gazing apps do that. And because they have your coordinate, they know where you are at all times. By the way, you can even point it into the ground, and it tells you about the sky that you can't see that hasn't risen yet. And so it's really good. And that way you can sort of work your way in to these, to what the sky, what your relationship can be with the night sky.
Cool.
And as always, visit your local planetarium.
Right, of course.
I slip that in there. Yeah,
exactly. Yeah, I mean, you had to do that. You get paid to say that.
We've got to take a break, but more of Cosmic Queries with PocketLab when StarTalk returns. Welcome back to StarTalk. We're in the middle of Cosmic Queries with PocketLab. So let's jump right back in.
All right.
All right.
Let's do Anna Victoria. And Anna Victoria Perez Leon wants to know this. How do we need to modify our approach to learning now that students have so much more information, yet less guidance? So I love this question. And I'm going to expand this question from Anna Victoria just a little bit wider. We live in an age of information now. Information is everywhere, period, not just for children, but for everybody. How are you able to process this information in such a way that you're able to separate the wheat from the chaff?
Okay, that needs to be a new part of the educational curriculum, which is assessing the reliability of your sources and your references. That was less necessary long ago. There was still some garbage out there, the chaff, the chaff is the bad stuff you don't want. There was still some chaff out there, but if you read a book, it went through a manuscript phase that got read by an editor, then a publisher invests in it, and then, so there are multiple filters that boosted the chance that what ended up in book form had some integrity to it, some academic authority and integrity to it. The pedigree of the author would factor into this. Today, since anybody can post anything on the internet at any time, anywhere, you don't have that built-in filter to the system. And so I don't know that the wheat has increased. Yes, it surely has. But what has definitely increased is the chaff. And I once tweeted, just if you Google Earth and you see pictures around Earth, I said, the Google flat Earth, and there are pictures of a flat Earth. There's a whole wiki page on the flat Earth. Google donut Earth. There's a donut Earth.
Sounds delicious. I want to live on donut Earth. I'm sorry.
So the fact that you can type these into a Google search, and each one of them gives you an entire wiki page describing that belief system. And if you don't otherwise know, if you're just an alien who landed here, well, you would know Earth was round. Plus, you have the technology to figure that out. So, not including aliens. Talk about if you're just born into this. If you were in a closet and you just came out and you're trying to understand the world, you would not know which of these to select. So, again, I got to put the burden back on school teachers. Somewhere in there, you need to teach students how to prioritize the sources of their information and the likelihood that something is true or is simply fulfilling a political, cultural, social, religious agenda in ways that then will mask what is otherwise objectively true about the world. And no, there's no guarantees here, but you can boost the chances that what it is you see, think, and do are connected to an objective reality. And as I've said many times, a search engine is the ideal way to confirm any belief you have, no matter what that belief is. All right. So if you want to say, come up with anything, you type it in, it goes through the world and it finds any other people who think the same way as you do. And then you get this false sense that your thoughts are legitimate because somebody else thinks it. Not because, So that's a problem that needs to be addressed. And I think you have to address it in the schools. It should be part of the curriculum. Squeeze it in, push something else out. I don't care how you do it, but it could be the unraveling of civilization. If people just say, oh, I don't want to vaccine my kids because look, and they type something in and out comes some gibberish about what people think what vaccines do to you other than prevent you from getting a virus. So you're getting fed information that is not authentic nor in your best interest, but you think it is. And that's the problem.
Cool. That's good stuff.
Yeah.
I got to tell you, I'm still stuck on thinking about really stupid aliens that land here and think the Earth is flat.
They'd have to come from space, and
yeah, they'd have to actually see it, and it could be a hologram. I don't know. All right, here we go. Wouldn't
that be cool if aliens spoke like that?
Yeah. Hey, what are you talking about?
Hey, Louie, how you?
It could be. Hey, what planet is this?
Who took the wrong turn at Alpha Centauri?
Oh God, here we go.
Those are aliens from Brooklyn.
That's what I was going to say. Only in New York would we come up with Brooklyn aliens. All right, here we go.
Yeah.
This is Anne LeBlanc from Anne is from Dartmouth. Ooh.
Dartmouth, New Hampshire, sure. Unless there's a Dartmouth, UK. I don't know.
Well,
but
right.
we were not very creative when we came to the New England.
No, that's true.
Everything they named it after everything else that they came from. New England,
right?
New Canaan, new this, new that, new.
Well, this used
New
to be
York.
Used to be New Amsterdam. And
yeah,
then
yeah.
Before it was,
can't you think up another name, old explorer people? Very disappointed. Plus, how new is New York? What we should call us York and the other one Old York.
Old York.
Yeah, that's how it should happen.
Right. There you go. This is what Anne wants to know. How do we explain the magnitude of space to a child sitting in front of a computer? Wow. That's wow.
Ooh, okay. So there's some fun YouTube videos that do zoom outs from starting on Earth and going to the edge of the universe and then coming back. And in fact, the American Museum of Natural History, which is my day job, we produced something called The Known Universe. It's got like a zillion views on YouTube, and give it to them and give it in full screen. And if you do one of those things where you can put it on a flat panel screen on the wall, so that it becomes almost cinematic rather than just looking at a small screen, that is a zoom, unnarrated, just visual trip from Earth to the edge of the universe and back. And you get a sense of the immensity of it all as Earth shrinks to this dot, as the solar system shrinks to a dot, as our entire stellar neighborhood, as our galaxy containing 100 billion stars shrinks to a dot in the distance. So that'll put him in, that'll set him straight right there.
Yeah, there you go. That's a cool thing. We did on the TV show, we did a bit where we started. It was like one of those Powers of Tens videos where we started at the edge of the universe and we kept zooming in until we saw Neil deGrasse Tyson laying on a lawn, and then we zoomed into his mustache and there was a whole nother universe.
I remember that.
Yeah, that was pretty funny. All right, here we go.
See, the jig is up.
Exactly. Okay.
What else you got?
Let's go. What's the most important? This is from Clifton Rooseboom, from Mountain View. Clifton says this: what is the most important astrophysics concept for everyone to know?
Oh yeah, no, I got this. Okay. It is. You need to know the immensity of space, which you would get in one of these Zoom videos. I mean, zoom out, not the
right, not what we're doing right now.
Not what we're doing.
Yes, exactly.
The immensity of space and the immensity of time. And I think those two are some of the hardest to grasp. And people don't really comprehend a million years, a billion years. They can't wrap their head around it. And so for me, it's not understand a black hole. Those are just objects that you can explain and learn. I'm talking about concepts. And once you get those concepts and you embed these objects in those concepts, then you have a true cosmic perspective of who and what we are here on Earth. There are people who are in denial of evolution because they say, how can a single cell become a human being with a brain and everything? Because they don't understand how much time has elapsed. They can't comprehend that. They're thinking, well, I don't see it happen because it's happening longer than your lifetime, longer than 100 of your lifetimes. And so at the geologic, how do rivers cut mountains and glaciers cut? That takes time. And if you sped things up to a time scale that's longer than human life, you'll get to see things happen. Volcanoes would come up and down. They'd repave. You got an earthquake. They get subduction of the continents. All of this would be going on like it's a daily thing. It just takes way longer than your lifetime to see it, know it, and embrace it. They used to call it deep time. And yes, time is older than the history of human civilization. And that's a concept that needs to come across.
Wow. Well, I don't know why I'm depressed now, but no, no,
Actually, there's an award-winning short film, and I think it's called The Wheel. It's a German film, very short. It's like 6 minutes or 8 minutes. Cool. I think it's called The Wheel, but to me, I just call it The Rock. Rocks. And what it is, it's a conversation between two rocks.
Oh, cool.
Okay, and things are happening in the background. You say, what is that? What is that? What is that? The sky is like pulsing in light. And then you realize those are days going by.
Right. That's funny.
So this is like the world as seen by rocks. And one rock says, oh, do you have a problem with lichens? I got itchy on the back of my neck here. And it takes a long time for lichens to start eating away at rocks. But to them, it's like it's their lifespan. And they're spending their whole time and they see trees come up and down and volcanoes and all of this. And then civilization shows up. And then a road goes by and it gets built like instantly in their reference frame. And then all the civilization goes away and they're still there.
Yeah, that's cool.
So, civilization, the time of civilization relative to rocks is very short.
Yeah.
Super cool. So fine. I think it's on YouTube somewhere. The Wheel.
All right.
I think it's a wheel because they find a wheel and they wonder about it. That the cavemen had just invented a wheel and they're admiring it, but then it just sort of dissolves in their hands because time moves quickly for them. But anyhow, check it out. That's a sense of trying to get a grasp on timescales and what effect that would have when you finally appreciate it and recognize what role it plays in trying to understand who and what we are in this world.
Excellent. All right, let's move on to Dawn Ritz. And Dawn Ritz is from San Diego, California. And she says, what would be a place in space that you would take a science class and why?
Ooh, I love that.
That's a great question.
I love that.
So what's your space field trip for the class?
Okay. Does it have to be a real trip or a trip that I'm imagining? Here's imagine. I would take a trip and we would go and ride alongside a comet. And you'd start from the outer solar system and it's just be this frozen ball. And as we get nearer the sun, the heat from the sun evaporates the frozen ice, the ice. In fact, the correct word there is it sublimates because it'll go straight from ice to gas. You'll see the tail grow. As you come closer into the sun, the inner planets begin to reveal themselves. You'll see Jupiter and then this asteroid belt and then Mars and then Earth and Venus and Mercury. And then you zoom around the backside of the sun and you come out the other side. So you get a tour of the solar system. You learn about comets. You get to see all the planets. And that would be my field trip.
Wow.
Except they take, to get a full trip there takes, depending on which comet you ride, would take a few decades. So your kids will be really old by the time it's done, but it would have been a trip of
It was worth it, though.
It was worth it.
Yeah.
Otherwise, you just put them in orbit. Have them take a few orbits around the Earth.
Okay.
And you see Earth from above, and you see like lightning storms and aurora, and you'll see 18 sunrises in one 24-hour period, because that's how quickly an orbit takes you around. So that would be, you get the overview effect, which astronauts get, where you see the Earth not as the color-coded ball, color-coded globe in your social studies class. You see it with no boundaries at all. It's oceans and land and clouds, and that changes you. And it's called the overview effect, which is a version of the cosmic perspective, which we all need if we don't otherwise have it.
There you go. All right, let's go to Emily Gonsalves. She's from Moose Creek, and she wants to know,
where's Moose Creek?
How would I know?
Okay. Okay.
I'm sitting here in Hoboken.
Hoboken, New Jersey. A lot of creeks in Michigan.
Yeah.
Maybe it's in Michigan. I don't know. Okay, go on.
So,
and it's got to be a place that has moose, right? So you got to be like north.
That got to be, yeah, exactly.
Could be Alaska. I don't know. Okay, but go on.
Okay, so she says, how should I be tying my love of all things space into my English class? Ooh, a little cross-disciplinary love going on there.
I love it.
Nice.
Cross-pollination, yes. Okay. There's some literature that actually makes interesting mention of space. So, for example, in Kurt Vonnegut's novel, Slaughterhouse-Five, it involves cleanup efforts in Dresden after the bombing of Dresden in the Second World War. Okay, fine. But the rest of the book folded into that is the encounter that the protagonist has with space aliens. And he has access to the fourth dimension in doing so, where he sees his entire life all at once. He's always being born. He's always dying. He's always living it out in between.
He's Dr. Manhattan,
for example, and from Watchmen. And so so the aliens give him this perspective, but the cost of that is they put him in a zoo for the other aliens to see the Earth creature that's there. But because he's not bound in time, it doesn't matter that he's in the zoo cage, because he can just go to anywhere else in his life that he has lived. So there's stories such as this. You can read War of the Worlds, which involves invading space zones. This is classic literature, written, of course, by H.G. Wells. You can be Time Machine, once again, by H.G. Wells. It's literature. Does all literature have to be Faulkner and Hemingway? No. There's other literature written by great writers who, and forgive me, I know only primarily the English English language writers. There's surely others in other languages. I'm just saying you can tap these stories and then analyze them for their scientific creativity. And those writers are brilliant. They have brilliant command of the English language. So you can definitely fold these lessons in. So that's what I'd recommend.
Okay. So I'm trying to get as many in here. I mean, first of all, we got to stop asking teachers for questions, because first of all, teachers have great questions. Secondly, it's so difficult to choose which question you should ask, because they really are thoughtful in the way that they're on it, man.
I just want to thank you guys for being on it. We've got to take another quick break, but when we return, I will introduce to you one of the co-founders of PocketLab. Welcome back to StarTalk. We're in the middle of a live cosmic query in collaboration with PocketLab. And for this last segment, I want to bring on one of the founders of PocketLab, Dave Baker. Check it out. All right, so Dave just showed up.
I see Dave. Dave's popped in, so I guess we're done.
We're going to wrap up, and we're going to do more Q&A.
All right.
Okay.
You guys are right. All the teachers we got thousands of questions, literally. We sent them to the StarTalk team, and it's a stack of paper. I appreciate everybody's perseverance. If you got your question answered, you're lucky.
Dave, let me just say this to all the teachers. Many of you think very much alike. If I didn't ask your question, I didn't pick one person's question over another. It's just that for every question I read, there were maybe 25 other teachers who asked a version or similar version of the same question. So thank you, guys.
All right, so Dave, you got some questions.
Yeah, it was great. Just a couple of things. I love Kurt Vonnegut. That was one of my favorite novels. I think it was Billy Pilgrim was the protagonist.
Yeah, Billy Pilgrim. That was the name of the protagonist in Slaughterhouse-Five. Yes.
Slaughterhouse-Five, yeah. That's one of my favorite. The other thing I wanted to mention, you were talking before about being able to discern truth from fiction. My eldest daughter went to UW.
But by the way, just not to be nitpicky, but I do not hold the word fiction as an opposite word to the word truth.
Yeah.
Okay, if there's something true and there's otherwise false. Fiction is a different thing. Okay, it's a different, we're communicating ideas and stories. And you're not, while you're reading these stories, saying, that's not true, that's not true, that's false. No, you're saying there are lessons here to be gleaned, even though the character does not exist, even though the storyline has never occurred. So there's a fact or fiction. I want to reserve the word fiction for its own genre, rather than thinking of it as the opposite of what is fact.
Well, you'll be glad to know. So,
by the way, I feel the same way about the word myth. Is it true or is it myth?
Yeah.
You know, myths are stories. They're like, as I described for the word fiction, they're stories of great tales that have deep insights, that offer deep insights into our lives. I don't want to think of myth as something that's just not true. It doesn't matter that a myth is not true if it otherwise has great value to us. So just use the word false. Is it true or is it false? Rather than is it true or is it myth? Okay, so that's my 2 cents.
That's great. That's interesting. Well, myths are important, right? My eldest daughter went to UW. They actually have a class.
UW, University of Washington.
Yes, University of Washington. Go Huskies! And the class is called "Calling BS in the Age of Big Data."
Nice. So we need that in elementary school.
Yes.
And then you call it calling bologna sandwich in the age of big data.
That's right. Yeah, you do need that.
How do you spot the bologna sandwiches? Yes,
that's right. So I got a couple of questions for you. One thing I was thinking about, teachers, we're all of us, teachers especially, are being forced to learn a new skill, and that's video conferencing. We work on video conference. We organize. We teach. We communicate. We meet new people, and it's been a struggle, right? And I think there's been a lot of stress. But is there maybe a silver lining? Is this like a tool that we're going to have in our toolbox that years from now we're going to look back and say, remember that the COVID pandemic, good thing we learned video conferences. It turns out it's really useful.
Yes. Okay, next question.
Okay.
No, let me offer some reflections on this. First, yes, the silver lining of all this Zoom calling and otherwise video chatting is, and I'm going to answer this from the point of view of an astrophysicist. Okay, what it has done is, I don't know if you've ever thought about this, but anytime you've ever met someone for lunch or for dinner or you would say, okay, I'll meet you at 10 o'clock. Well, that's insufficient information to actually meet them, because you have to then give a location. Built into our lives and our social discourse is communicating a time and a place. This is the space-time coordinate system that Einstein tells us about. We live in space and we live in time. And you will only meet that person if you are in the same place at the same time. That's why you can't give just one of those and have it be a successful meeting. I can't tell you, I'll meet you at the corner of 5th Avenue and 45th Street. When? Okay. Well, again, I'll meet you at 2 p.m. Where? All right. What video conferencing made for the masses has done, it has separated those two coordinates. So now the where doesn't matter, because the where is now distributed into everyone's computer. And all that matters is the when. And as a result, in this coronavirus lockdown, I have attended more science seminars than I ever did in the last 5 years, because I can't always be in the department when my colleague is speaking, because I'm on tour, I'm in this, I'm that, and but now it's a 45-minute thing. I've got time on let me dial in. And so the Zooming, as distant as we are from each other, in fact, the silver lining is that we've never been closer, simply because we can communicate. in ways that we care about, with body language, with gestures, with, oh, where's that? Oh, show me what you got in the kitchen. Or you carry around the device. So by being more distant from each other, there's a part of it that actually makes us closer together. And if we carry that forward out of the coronavirus, it's definitely another key tool that I think teachers can use and invoke to deliver content and instruction and whatever else is necessary to get the job done. So that's how I think about it.
Yeah, it's great. You know, a great example, Chuck and I never met in person, but we were working on this project. We know a lot about each other, and we made a ton of progress. We didn't have to meet. I would love to go and have a drink with Chuck, but we just can't right now. And it's okay. It's not great, but it's fine. It's working.
Mm-hmm. Don't worry, Dave. I have a mask with a hole in it and straws.
Okay. If we could both get permission from our spouse. So Chuck, this is great. Another thing I'd love to have your thoughts on. We have thousands of science teachers here, and with this in the last conference, and we're going to do a ton of these, we have tens of thousands, if not hundreds of thousands, of science teachers. Have you ever thought, is there if you could have a goal, if we could all organize and get together and have a single mind as science educators and set like a 5-year or a 10-year goal to really change education and change the next generation of young students, what would be like the top couple things that would be worth focusing?
This brings us, that's a great question. And it brings us full circle back to was it the very first question that Chuck pulled up, which is, I think it's too short-sighted to say, here's what we should do, and here's what you should know, because that could change. That might need modification. That might need to be adjusted based on culture, politics, whatever are the forces operating, budget, whatever the forces operating at the time. But if you successfully instilled a sense of curiosity aiming to find out what is objectively true, that is something you carry for your lifetime. That's something you carry into every room you step, into every conversation you have, no matter how powerful the person is with whom you have that conversation. Being curious about what is objectively true enables you to navigate a path of inquiry to arrive at that truth. And almost anybody enjoys that journey. I think people, if you can say, well, let's think about it this way. Well, I never thought about that. Well, if that's true, then this could be true. Let's check that. And you just navigate this together, and then you arrive at sensible, wise conclusions together. So this is a tool that students need to have. So as teachers, especially as science teachers, except there was one English teacher out there who asked about the novels, totally welcome you there. But especially as science teachers, who are the keepers of the search for what is objectively true in the natural world, that those tactics are what matters here. Okay, and let's go to the social sciences and the liberal arts, where you do a research on a research topic, on a paper, right? You write a paper. I guess they still do that in high school, maybe not in elementary school. But there's a topic you don't know much about. How are you going to research it? What are your sources? How are you going to trust those sources? What conclusions will you draw based on this? This is all analysis, and not enough in the school system is about analysis. It's all about knowledge, like you're some kind of empty vessel, fill it with knowledge, and now you're done. Let's process you and send you on your way. I'd rather you started out as an empty vessel and ended as an empty vessel, except you had a toolkit around you to feed that vessel with whatever you encounter later on, and know how to establish what is objectively true in what it is you have investigated. Once you've done that, you won't have any of this. You won't have flat earthers. You won't have vaccine deniers. You won't have climate deniers, because they would have understood what the path is to find out what is objectively true. And they will know the risk of their bias, cultural, political, social bias, influencing what it is they're thinking. And to be scientifically literate is to have this fluency in inquiry, in knowing how to ask questions, and knowing when you have arrived at an answer that has sufficient data to support your conclusions. So I've always said to be scientifically literate is to be inoculated against charlatans who are out there, against people who think they know what they're talking about, but in fact don't. Because the biggest challenge we have just as a species, as individuals, is thinking, I've said this before, thinking you know enough about something to knowing enough about something to think you're right, but not enough about that same thing to know that you're wrong. There's this valley in there, and there are a lot of people that are sitting in that valley who don't know enough to know that they're wrong, but know just enough to think that they're right. And if those people ever rise to power, and if they do, and when they do, it's dangerous. It, like I said, it's the unraveling. It's too late.
Too late, Neil. You're too late. Sorry, buddy.
Yeah. So these are my words of wisdom in whatever way they can land among the teachers out there.
I think that's fantastic. I think that's a goal. I think that's something to think about. You remind me, I had a great mentor in my life who always told me, you have to invest in yourself, in your education, because no matter what happens in your life, nobody can take that from you.
Yes, that's correct. That's right. It becomes part of who you are and what you bring to every next encounter and challenge that life delivers. And I want to, if I can, and I know we're running long, I want to end with one sort of something about which I feel strongly, okay? Every teacher tuned in right now was once a student, okay? We were all students at some level of the educational pipeline. As a student, we all had some great teachers and we had some crappy teachers, okay? And we remember them for being great and we remember them for being crappy, okay? And those teachers who were great, you just enjoyed being in their classroom. They had an enthusiasm, an expertise, a command of the content where you just wanted to bask in their brilliance. And it wouldn't matter what the subject was. You can have a favorite subject over here, but they're a great teacher in this other subject. They make that your favorite subject that semester. You know you had those teachers. And by the way, how many of those teachers did you have? I've done this exercise, okay? I've been in a room with thousands of people. I say, how many truly great teachers have you had in your life? Most people, it's like it fits on one hand, maybe 3, 5 at tops. Most people, it's 2, and some of them, it's just 1. And I say to myself, this is out of scores of teachers, in some cases hundreds if you went through college and graduate school. There's only this many? Well, those are the super teachers. So here's my challenge to every teacher tuned in right now. Be that super teacher that you know you had as a student. Be that teacher. And if you become that teacher, and you might already be that teacher, I don't want, I don't want to call out stuff that doesn't need to be called out, but we know as students, as having been students, who these great teachers are. Become those super teachers. And if you do, you will transform the school system overnight.
Yeah. It's great. And, I tell you something about the audience who comes to these. I think a lot of them are those super teachers. But that's why they're here. This is the summer. You're supposed to be on vacation. What do? You're going to spend all day listening to us. That's because
right. It means you're committed.
You're committed.
You're committed. Yes.
So it's fantastic. Neil, those are great words to end with. Chuck, thank you so much. You guys were fantastic. The chat is going by. They're going crazy. Okay. Great job.
We've got to wrap it up here, but thanks for tuning in to this special edition of Cosmic Queries in collaboration with PocketLab. And I want to thank PocketLab and their organizers and all the teachers who participated in this live Cosmic Queries. And as always, I bid you to keep looking up.